got two additional IR videos that I want to show you, and this first one is going to focus on the alkene region and what we can determine about the substitution pattern on an alkene. These spectra are all taken from the AIST database. So the first one I'm showing you here is Trans3 Hexene, and you can see that we've got our standard sp3 carbon hydrogen stretching in the 2850 to 2970 range, just on the low energy side of 3000, but we've also got a peak here, right, at 3028 that has a 66% transmission, right? It's nowhere near as strong as the sp3ch, but this is the sp2 carbon hydrogen stretching that you're seeing there. We've also got a strong peak here at 965, right? Only 13% transmittance. That is the peak that tells you this is a trans alkene as opposed, or an E-alkene as opposed to like a vinyl group. We saw in the previous video on a vinyl group that you'll see two peaks down here at about 910 and 990 instead of just a single peak. You'll notice we got a CH2 scissor here at 1462 with 32%. We got our methyl rock at 1375. I would expect to see those, but you'll also notice we don't have a peak at 1600 at all. Because this is very symmetrical, there's no significant dipole change when you stretch the carbon-carbon double bond. So the trans alkene typically does not show that carbon-carbon double bond stretch in the 1650-ish range that you'll see for the vinyl group and for other substitution patterns. So we're limited. We know it's a trans alkene because we know it has some unsaturation in it. We have an sp3 carbon hydrogen stretch, and then we have this single fairly strong peak, in this case at 965. If we look at the corresponding cis 3 hexene, you'll notice immediately that there is the carbon-carbon double bond stretching here, and we've actually got two of them at about 1666 and 1685. Right? So that's the carbon-carbon stretching region. We have our CH2 scissor, as you would expect, and our CH3 rock at about 1370. And then we also have our sp2 and our sp3 hybridized carbon-carbon stretching. This peak at 3164, that's just a ghost. But this peak at 3008 with a transmittance of 10 is the carbon-hydrogen stretching. And you'll notice it's quite a bit stronger for the less symmetrical molecule because of the larger dipole change. And then there's a broad peak, and just one of them here at around 716, around 700. A single peak at around 700 is indicative of a cis alkene, whereas the trans alkene had the single peak at about 950, 960. Right? So there's a big difference between the cis alkene and the trans alkene, both in the carbon-carbon stretching region and in the alkene bending area. A geminal substitution pattern here, where the two ethyl groups are attached to the same carbon. So we've got 3-methylene pentane, or you could call this 2-ethyl 1-butene. Right? There's a 2-ethyl group here, carbon 1, carbon 2, carbon 3, carbon 4. This is 1-butene. 2-ethyl 1-butene is the IUPAC name. Pretty good carbon-hydrogen stretch at 3084, right? That's the sp2ch stretch. Here's the sp3ch stretch. And then we've got a strong carbon-carbon double bond stretch at about 1650, right? Because there's a great deal of asymmetry, so there's a large dipole change when you do that. And then a single peak here at around 890, 888 in this case. That is typical for a geminal substituted alkene bending mode where the two hydrogens are attached to the same carbon, right? CH2 scissor, CH3 rock, those are almost always present. A tri-substituted double bond has yet another different pattern here, right? This tri-substituted bond 3-methyl 3-hexene now has a single peak, kind of split into two closely one, but 840, 860, right? At about 850-ish, somewhere between 800 and 850, the single peak there is typical of a tri-substituted double bond. Right. Got a relatively weak carbon-carbon double bond stretch. The carbon-hydrogen stretch for the sp2 hybridized carbon is almost invisible now because there's just one of them, and it's a relatively weak peak. Right. But we see a strong sp3ch stretch and our usual CH2 scissor and CH3 rock. So this peak here, right, this peak in this region here in the 700 to 950 range, that's what enables you to determine the substitution pattern on alkene. Tri-substituted single peak somewhere between 800 and 850. Geminal single peak pretty strong at about 890. Cis one peak at about 700 or so, and the trans a single peak fairly sharp and strong at about 950 or so. And then the vinyl group, which we saw in the previous video, right, that's the one that has two peaks at 910 and 990. So if you know you have an alkene, the IR can often help you determine what your substitution pattern is on the alkene.